Welcome to the Smarter Science of Slim, the scientifically proven program where you eat more and exercise less to burn fat and boost health.
Eat smarter, exercise smarter, live better. I am so ready for that.
Hey everyone, Jonathan Bailor back with another bonus Smarter Science of Slim podcast. Folks, today's show, I gotta tell you, this is pretty cool. I mean, this is a subject that, we're all about living better and just cutting edge science that can help us live better lives. And we have a guest, a brilliant researcher, professor, author, speaker, just superwoman of sorts, who's done some research. I've literally never seen anything like this before, and it is just cool stuff. She has been a cardiologist for over 20 years at the UCLA Medical Center. So no woo-woo here. She is a professor of medicine in the David Geffen School of Medicine. She's also doing all kinds of stuff with the Los Angeles Zoo. She recently wrote this amazing book that we're going to talk about today called Zoobiquity. And I'm going to let her describe what she does because it is literally amazing. Dr. Barbara Natterson Horowitz, welcome to the show.
Oh, I'm so happy to be here.
Well, Dr. Natterson, your new book, Zoobiquity, it covers something like a species-spanning approach to medicine that I have never heard of before. Can you tell us a little bit more about this?
Sure. Well, I am a cardiologist. I've spent a couple of decades taking care of people with high blood pressure and heart attacks and cholesterol issues. But then several years ago, I had this wonderful opportunity to go to our local zoo, the Los Angeles Zoo, and assist some of the veterinarians with some of their cardiac imaging issues. And, although zoos around North America are staffed by incredibly qualified vets who know how to brilliantly take care of their patients, from time to time, they will call on colleagues from the human side to come and participate in the care of the animals. And I was one of these lucky physicians. So I started hanging out with the vets. And I have to say, until that point, the only time I ever really encountered veterinarians when I was taking my own animals in for, vaccinations or minor issues. And so here I was listening to these veterinary doctors talking about breast cancer in lions and, obsessive compulsive disorder in polar bears and diabetes in kangaroos and on and on. And it occurred to me that here I'd spent, over 20 years taking care of these same problems in my human patients. And I simply had never thought about the world of veterinarians and their patients who were dealing with the same issues. So that's how this whole thing started, with this opportunity to visit with the vets at my local zoo.
And Dr. Natterson, let me pop out to why this is, I think, so cool and in some ways a whole new field of medicine, which gets me really excited. I'm a science geek. I love reading studies. I've read many of them. And we know the importance of animal models, studying in animal models, because we can do things in animal models that we can't do in human models. Plus, there's also, like, when you use a mouse and you study eating patterns, there's not as much emotional eating and societal influences. Like, we can just look at the mammalian behavior. But you've actually seen that maybe if researchers previously thought, okay, there's the way humans act and think, and they have this emotional side, and then there's animals, and they're totally different. You've actually found some amazing parallels, haven't you?
Yeah, I mean, one of the most exactly the surprising aspects of this whole project was asking the questions, do animals blank? And assuming the answer would be no, because I assumed certain behaviors had to be uniquely human. So, let's talk about eating behaviors. So one of the questions that my co-author, Catherine Bowers, and I asked was, do animals ever get fat? Do they ever become, clinically, medically obese? We also asked, could an animal get an eating disorder? Do animals ever self-induce vomiting, for example? Or would animals ever engage in secret eating or the hoarding of food or other disorders that psychiatrists would consider pathological on the human side? And it turned out that the answer to each of these questions was yes. And not only do these behaviors happen in animals, very often the animal experts have very interesting and effective approaches for dealing with these problems. So just to start with the do animals get fat question, do they become obese? Animals are becoming, particularly companion animals, our companion animals are getting, unfortunately, fatter and fatter. Many are overweight. Probably about 50% of our dogs and cats are overweight, and about 40% or so are actually obese. It's such a significant issue that veterinarians there's a diet pill, for example, that is now indicated for obese dogs. There are dogs who have actually undergone liposuction. There is a diet that's recommended for some obese felines, which is a very high protein, low carbohydrate diet that they, of course, call the Catkins diet. Yeah, I mean, it's incredible. There are actually some veterinarians, some zoo veterinarians who several years ago began putting some of the animals under their care on a kind of Weight Watchers point system type approach. And it goes on and on. So, I mean, perhaps it's not that surprising that companion animals are getting fatter. I mean, they're under our supervision. We under exercise and overfeed them and, don't give them the right kinds of food, perhaps just as we don't do that for ourselves. But it was interesting in our research to learn about even some wild animals who are also seem to be getting fatter. And when we talk to some ecologists and wildlife biologists who have spotted this trend in certain populations, we're talking about some marmots, some rats, some marine mammals, they have some hypotheses that there could be environmental effects, whether these are endocrine disrupting chemicals in the environment, antibiotics, other issues that could be contributing to this. Well, the other really interesting and unexpected area that we found similarities in was the issue of eating disorders, of actual eating behavior. So I guess before doing this book, if you'd asked me, do any animals other than human beings overeat? I think I probably would have said no. I would have assumed that wild animals, for example, had these internal self-regulatory mechanisms that led to them never eating beyond satiety. Well, it turned out that that's completely wrong. We met with some veterinary nutritionists who worked in the wild who said that, in fact, almost all wild animals, if given access to abundance, will actually overconsume. That from an evolutionary perspective, that makes sense. That, in nature, periods of abundance are almost always juxtaposed with periods of scarcity. And so the drive to overconsume really makes sense. So knowing that, it kind of, in a way, helped me better understand my human patients who struggle with overconsumption. In a way, it allowed me to think of it in a not to normalize it in the sense that it's okay to do from a health perspective, but to understand it in a broader context. The other really interesting and unexpected eating behavior that we learned about was the incidence of something called regurgitation and reingestion, which is seen in great apes like gorillas and chimpanzees and some marine mammals like beluga whales and dolphins. And this is a behavior where animals, typically when they're encountering social stress, will actually induce emesis. They'll induce regurgitation. They'll make themselves vomit. And they do this repetitively. Sometimes they will reconsume the matter that they have vomited and then vomit again. So they're engaging in a kind of compulsive regurgitation syndrome that seems to be done to sort of soothe them because it happens during periods of social stress. So those kinds of parallels were eye-opening for me and have allowed me to think about human eating disorders from food hoarding, anorexia nervosa, bulimia nervosa, et cetera, from a very much broader perspective.
Dr. Natterson, you mentioned that three things all related. I'm very excited by what you're talking about. Three things all related. One is that obesity, overweight in animals seems very closely tied to the domestication of animals, meaning like, dogs and cats, things we have as pets. Having them as pets, aka domesticating them, seems to correlate very strongly with these obesity and related conditions. And then also, even if not domesticated, if their environment, their natural environment, is somehow denatured, aka it's not really their natural environment anymore because it is being interfered with by human-induced toxins or something along the likes, it's been adulterated in some way, they also experience these diseases typical of civilized humans. Am I understanding that correctly?
Yeah, I mean, unfortunately, our cats and dogs are encountering the same sad collection of medical problems associated with obesity that we have, from diabetes and hypertension. All of these are happening as a consequence of overconsumption. One of the things to think about, though, is that in the wild, animals' weights vary. That's normal and that's expected. So when there is abundance, animals overconsume, and then when there's scarcity, their body weight goes down. That variation is normal and speaks to sort of the cyclical nature of what happens in the outside world. I'm not sure exactly how that applies to the human case, but I think it is interesting that that mammalian metabolism evolved in a setting in which the environment kept shifting, and that it's likely that up until very, very recently, even the human body weight shifted based on the seasons. So that is interesting, because typically as a physician, I don't like to see big shifts in my patients' weights. I mean, the ideal is to have a patient be at an optimal weight where their blood pressure is normal, where they're happy and comfortable, and their lipids are outstanding. I mean, that's what we like to see. We don't like to see kind of a waxing and waning. But in fact, in nature, it's very different. So
Doctor, sorry. So what did you see, or what did you observe in? So there are certainly there are seasonal climates, but there are also Mediterranean type climates, or climates near the equator, tropical climates, where an animal who eats nothing but plants seems to have access to unlimited amounts of plants all year round, yet they do not become morbidly obese. What's taking place in that animal?
Yeah, well, again, I can't answer for sure. I can just share with you some of the ideas that the research has sparked. Well, based on what we've learned from these veterinary nutritionists, the desire to overconsume is there, but animals are, in the wild at least, their eating is regulated by, in part, danger. So predatory threat becomes a significant factor in how often animals will feed versus hide, when they'll come out. So in fact, in environments where predators have been culled, and one example of that was in Yellowstone when the wolves were removed many years ago, the elk began grazing more hours per day. They got heavier. There was a shift in their body morphology. So my suspicion would be that wild animals who live in settings of constant abundance don't ultimately overconsume, because there is a constraint imposed by the predation risk that they encounter daily.
It's fascinating, Dr. Natterson, because there seems to be a bit of a dichotomy in the research, because I know there was a big struggle, at least in mice and rats, like prior to the advent of the cafeteria diet, trying to fatten these experimental animals just by giving them more rat food was difficult. Like, they would literally try to pump rats full of food into their stomach, and the rats would just stop consuming food voluntarily to avoid chronic obesity. So I'm curious if you have any insight into that.
No, I mean, I think this is, I can't speak to answer that question, other than to say that I think there's no constant, there's no one answer, and species are as varied as they are. We know a tiny little bit about this whole question of appetite and metabolic regulation. I mean, it's exciting to be at the beginning of this, but what I'm sure about is taking a comparative approach, and that is looking at metabolism, hunger, satiety across species can generate new hypotheses. One of the problems is, as physicians, we only look at Homo sapiens, and that's been limiting us.
I love that. And I think and the reason I'm digging on this one area, for lack of better terms, is there's obviously been this big push, it seems, and a lot of success by Homo sapiens to say, if you just eat things that Homo sapiens ate historically, like not processed garbage, but rather things you could find in nature, the natural diet for humans, it becomes very difficult. And there's tens, hundreds of thousands of people who will tell you, like, it's very hard to overconsume non-starchy vegetables and nutrient-dense protein. Like, it hurts before you would eat too many calories.
Yeah, well, I think that's a really good point. I think that's a great point. Yeah.
So I am just curious because it's almost like we learn, one of the things you learn from the animal kingdom potentially is the more something becomes divorced from its evolutionary context, it seems things tend to go downhill when that happens.
Oh, yeah. I mean, you can look at a lot of diseases from the perspective of a mismatch between what we evolved, the environment in which we evolved, and what we encounter today. There's an emerging field called evolutionary medicine, which is looking explicitly at this issue, how to understand why we get sick. And much of the time, the reason we get sick is that we've created environments, built environments, biological environments that, are very different from the way we've evolved.
And what are the most compelling hints you've seen from the animal kingdom, especially maybe our close ancestors like apes and such, where if they're put in these social contexts or if they're given these cues, things get better for them? What are some promising areas there?
Well, I think, a couple of areas which is kind of the low-hanging fruit is the behavioral stuff. When vets encounter animals who are getting fatter and are unhealthy, particularly animals, let's say, who are in captivity or perhaps are under our care and in a variety of situations, you can't talk to an overweight bear, let's say, or an overweight monkey or whatever about showing more willpower or making better food choices, right? That's impossible. But what you can do is you can modify their environment, and they do something called environmental enrichment. They will make the enclosure, this is in zoos, for example, they will make the enclosure more complicated. They will make it challenging for the animal to access their foods. They actually they have toys that are called environmentally enriched toys, and they'll stuff the food in difficult to find places. So what they're effectively doing is they're making it harder, more interesting, actually more intellectually challenging to access the foods versus, strapping on a feed bag and just letting them feed at will. And it's funny, as I was learning about all the ways that vets deal with animal obesity through modifying the environment, environmental enrichment, it began affecting how I was shopping for food for my own family and thinking about how I accessed food. So, I have always been pretty interested in nutrition and kind of eating whole foods and whatnot. But I hadn't spent a lot of time thinking about how a longer prep time could probably lead to me consuming a little bit less of what I didn't need. And a longer prep time could probably be more gratifying for my family if we all participated in it. So it actually started influencing me a little bit. But what vets do with environmental enrichment is very powerful. They're able to treat veterinary anxiety, animal anxiety, which is a very significant problem for dogs and cats. And they're able to treat compulsive disorders, particularly canine compulsive disorder, with modification of the environment. They deal with bullying that way. So that's one of the interventions that I think there's a lot of promise for. And I've actually encouraged our Department of Psychiatry here to consider sending the residents in psychiatry to spend time, maybe a week or so, with a veterinary behaviorist to learn how they do it with animals that can't use language to communicate what they're feeling and what's working.
And is this, do you feel that there is obviously there seems to be much to learn here, and is that really because, on some level, like especially we've shown the genetic similarities between certain species of apes and humans. I mean, we have the quote unquote animal part of our brain. Obviously, you're the expert here. And is that what we're seeing patterns? Like the amygdala works this way in mammals, kind of. Is that what we're seeing? Or?
Yeah, I think there's a lot more that's conserved than that's different. And that's been the big light bulb. If you ask most physicians about it, they'll agree with you almost instantly, but we don't think that way. We tend to think these issues are uniquely human. So when I first started learning, for example, about post-traumatic stress disorder in dogs and anxiety disorder, and by the way, I have to tell you that I'm a very skeptical person. I was my co-author and I, approached this entire topic, particularly of animal psychiatry, with tremendous skepticism. Neither of us knew much about it. But I became convinced that, in fact, absolutely animals can suffer from anxiety disorders. They absolutely can suffer from a canine form of obsessive compulsive disorder. And actually, the gene for canine compulsive disorder has now been identified by Nick Dodman at Tufts. So these things that I, let's say, used to assume were uniquely human, were not. And as you begin realizing that they happen in a very similar way in non-human animals, you then have to look at the conserved biology that, yes, it's shared neurochemistry. It's that fear and anxiety are ancient. Mammals have been on Earth for about 200 million years, but we know from veterinarians who specialize in reptiles that even reptiles, snakes, and lizards can develop what they call an emotional tachycardia. Tachycardia is the medical term for an accelerated heart rate. That they can develop an emotional fever when they're scared, when they're handled too much. So in fact, even something like anxiety is even older than 200 million years. So these emotions, that would include, my guess is, the relationship between fear, anxiety, food, resources. All these things these responses are shared by many animals with whom we shared common ancestors literally hundreds of millions of years ago.
So we're seeing the overlap of human medicine and evolutionary biology and veterinary medicine. And what gets you most excited about the confluence of those three disciplines?
Oh, we're at UCLA. We've just started a program in evolutionary medicine. The chairman of evolutionary biology, Dan Blumstein, and I are really excited that UCLA undergraduates can now minor in evolutionary medicine. And we're starting our first cycle of courses this year, and I've been putting together lectures. And I started by just drawing a timeline of disease. So it's literally like one of those timelines everybody looked at in school, where you have the present on the far right and the way, way, way past on the left. And as I began looking leftward, I was able to put diseases. We've seen paleontologists have found evidence of cancer, for example, in the bones of dinosaurs. So I put at about 100 million years ago cancer. There's evidence of diabetes in hoofed animals and members of the order Carnivora. So I was able to write diabetes at least 60 million years ago. Gout, arthritis, stress fractures, also seen in dinosaurs, able to add that to the list, and so on and so forth. So this idea that these disorders that I've been taking care of since I became a doctor have actually existed in animals, now long deceased animals, but their ancestors still bear these genes. So these disorders are not only not uniquely human, they are not unique to our contemporary times. That, for me, is a mind blower.
I love it. I love it. Well, what's next for you, Dr. Natterson? What's next for you? The Zubiquity movement, UCLA. What's going on in the future?
Right. Well, we have been putting together these conferences to bring together veterinarians and physicians to talk about the shared diseases of their different patients. At past conferences, we've looked at obesity, we've looked at bullying, we've looked at self-injury, cutting, because of course animals self-injure, unfortunately, in response to stress, just as some humans do. But our next conference we're most excited about is going to be in New York on November the 2nd, and it's going to be jointly sponsored by the Wildlife Conservation Society of New York, which oversees the zoos and aquariums in New York and does a lot of international outreach for wild animals. The Animal Medical Center, a very prominent, long-standing purveyor of veterinary services in New York City, and UCLA. And we are going to have some of truly the leaders in human and veterinary medicine. We have the deans of vet schools. We have Dr. Harvey Feinberg, who's the president of the Institute of Medicine, coming on the human side. And in the morning, this group of 300 physicians and veterinarians are going to be discussing breast cancer I think we have a beluga whale case on the animal side and a cat case on the animal side, and we have a couple of human cases, women with breast cancer. We're going to be discussing anxiety disorders. We're going to be looking at eating disorders across species in the morning. And then at noon, this entire group is going to get on buses and we're going to all go to the Bronx Zoo, which is a wonderful, I think it's the oldest zoo in the United States. And we're going to be going on walk rounds led by the very prominent veterinarians there at the Bronx Zoo. So it should be a wonderful day. Any physicians, veterinarians, even nurses, psychotherapists who are interested in these connections between the disorders of humans and animals should look into it. It's going to be a great day.
Dr. Natterson, that sounds very, very, very fascinating, just as fascinating as your wonderful book, which again, folks, is called Zoobiquity: What Animals Can Teach Us About Health and the Science of Healing. And you can learn more about that book, as well as our wonderful guest, Dr. Barbara Natterson Horowitz, over at zoobiquity.com. Dr. Natterson, thank you so much for sharing your time in this very interesting research with us today.
Oh, Jonathan, it's been a pleasure. Thank you so much.
Listeners, I hope you enjoyed this conversation as much as I did. And please remember, this week and every week after, eat smarter, exercise smarter, and live better. Chat with you soon.
Wait, don't stop listening yet.
You can get fabulous free SANE recipes over at carriebrown.com.
And don't forget your 100% free eating and exercise quick start program, as well as free, fun, daily tips delivered right into your inbox at bailorgroup.com. That's Bailor group.com.